take a second to introduce myself. My name is Maloney. I'm a product manager with AWS. And again, I sort of give you an overview of what we're going to talk about today. So I sort of want to just dive in again in terms of defining web applications and what they might mean and how they might interact with your agencies or your departments or organizations. So this really encompasses everything from, say, like your basic static website. There's often a lot of these running around where you're just serving static content, all the way to really sort of complex and dynamic applications that involve potentially millions of users that can be accessed through a huge variety of different devices, whether that's your tablet, your mobile phone, your PC, the various clients that use to access that access that application. And so here's a couple examples initially of some AWS customers. You heard from a couple today already that have really used the AWS platform to enhance engagement with their constituents. One of these examples is USDA. USDA, this is Snap from FNS, and what they're actually doing is providing locations to show people where they can redeem their benefits. Very simply, it's actually an Esri interface. You can come up, you can see the constituents can come on, view what they need to, and go through. And then obviously you heard from Recovery.gov today, so don't belabor that, but also, that gives you a very, very simple way of engaging with the constituents, showing them the information that they're interested in terms of tracking the stimulus spending. And then also the Department of Treasury, again, the Treasury.gov domain has actually 300,000 unique users a month. And they display everything from what the department's doing to news of the department and so forth, and done a really good job engaging their constituents in that manner. However, it's not always simple to run web applications, and one of the main reasons for that is it's really hard to predict demand. Demand is variable. Demand is it's really an unknown. And one example that was called out in Vivek Kundra's cloud computing strategy was from CARS, or usually known as the Cache for Clunkers program. And what happened in this case is that they were expecting demand to be in the order of 100,000 to 250,000 transactions, and that was really over a span of 90 days, or that was over the span of the entire application. And in 90 days, they actually went through 690,000 transactions. And what happened in this case is with an inflexible infrastructure, they happened to have a lot of outages. Actually, it was in and out constantly, and then it led to significant overruns because what they had to do is then rush all the hardware in to try to keep the application current. So the spend in the program went from $1 billion to $3 billion. And that's why it's commonly called out as an example. So managing this kind of unpredictability can be very difficult, and really sort of ends up being the focus of the presentation, because this is what happens a lot is we start looking at as demand increases in your application, what happens is eventually there's a bottleneck that occurs that starts degrading application performance, whether that's on CPU, whether it's memory, whether it's I/O. You're going to end up running into these bottlenecks, and eventually your application may be totally taken offline and stop running, which is the case of what happened in the last example. So we're going to go through some of the tips, some of the services we have that can actually make this a much simpler and much easier process. And so we really do that by offering the suite of services that have two very distinct characteristics. They're all scalable, and in that case we really mean elastic. You can scale them up, you can scale them down, and it's all available on demand so that you get exactly the amount of the resource you need exactly when you need it, which is fundamental in terms of simplifying the management of unpredictable demand. However, you can only really take advantage of these aspects as long as you know that the infrastructure underneath is reliable, secure, and cost-effective. And those are sort of the themes we'll be hitting on today. So just want to give one example of this. Playfish is one of our customers. Playfish is a online gaming company. It was acquired by Electronic Arts. And they say they had this issue where they were releasing games but really had no idea based off of social graphs what was going to happen to that game. And in this case, they were expecting around 150,000 users, 150,000 to 200,000 users for their new game called Restaurant City, which would have been a big success. What ended up happening is it went to 4 million users in 8 weeks. And as you can imagine, having to deal with that, with the complexity of scaling that with what would generally be more inflexible and static assets. It would be really, really difficult. And generally, as we saw in the original graph, your application is probably going to go offline in a case like this. And, what they did is they actually used a lot of AWS's tools, the ones we're going to talk about, to ensure that most of the scaling actually happened automatically. It automated that. It automated this scale. And so the developers were just sitting there continually trying to add features and work on the application while this type of scale took place, which is really obviously important when you're an online gaming company, and that's sort of the core work that you do. And so that's what we're going to talk about is what are the services that help in each tier of your sort of a standard end-tier web application. And so what we're going to do is we're actually going to start off here at the web tier. So we're going to talk a little bit about traditional here. So traditionally, what happens is we're going to have demand, and we're going to have the web servers to meet that demand. And so if demand increases, we're going to be adding the servers that we need to continually meet demand. This changes a little bit in the way that we should think about serving static content now, specifically with what we do with Amazon S3 and CloudFront. So if we have demand for static content, and you have that content in S3, we just saw the immense scale that S3 gives you initially. So I think it was in Werner's deck, he said the peak requests in Q3 were 370,000 requests per second. That's what that service can handle from a scale perspective for your static content. And so if you're putting the content in there and serving it from there in your application, that takes a large load off of your web servers. You can actually use S3 as that portion of your web tier, and on the slide are some examples of common things that we'd serve statically in a web application. This would be really, really effective and really powerful. Now, it gets even better when we actually attack, one of the points is just from that scale perspective, you just start adding and adding people, you don't actually change anything. S3 does it for you. It's just going to continue to be able to handle those additional requests per second. Unless you're getting up to, it sounds like more than 370,000 requests per second for your application, you're probably in good shape. And so the next thing I want to say is this gets even better when you think about delivering that content with Amazon CloudFront. So Amazon CloudFront is our content distribution network that integrates seamlessly with S3. So actually, if you put a file into S3 to take load off your web servers, you're saying, hey, let's take that load, let's deliver the static content with S3. I'm just going to right-click into the console and enable content distribution. Then you're set. You can go to any one of our 21 POPs and ensure that that static content you're serving is right next to your customer. And actually, to note, in using CloudFront in many cases is actually cheaper than using S3 to serve the content directly. So you're going to get better performance and actually continue to lower your prices, which is nice in the mix of that. So this is sort of traditionally what we see on the screen. We're pointing to what would be if you're just delivering it for S3, or in this case, some other data center. The request for that content is going to go in to the data center, and it's going to come back. And there's obviously latency, and then that sort of impacts the constituent experience or the ability that they have to interact with the application that you're serving to them. And so in this case, we just go to the latest POP, and just right-click with the mouse, set up the POPs on demand the way we want to. It'll scale to the scale that you need to match, and you're set up with a low latency static content delivery that basically has one-to-one scale, linear scale with the number of requests per second that are coming into your application. So that can really help with CPU bottlenecks around your web tier. It can really help to simplify your application and the management of that application when demand fluctuates. The advantage is you also get perfect cost efficiencies in this manner. First of all, S3 is really inexpensive to use and serve those requests, but you're only paying per each server and each request coming in and the content going out. So you're really matching that one-to-one, so you're getting the exact utilization you want. You're actually getting utilization not down to a micro or a small or these different virtualized server levels. You're actually getting utilization down to the request level, and so it doesn't get much better than that. So now we're going to move on to the web and the application tier in terms of managing demand with Amazon EC2's instant elasticity. And Peter brought this up a bit in the Hadoop one if you were in for the big data presentation. I know a lot of you were, in terms of we just spin up these big clusters and then we shut them down. And the same concept holds true, and it can be really important, for dynamic web content that you're serving. Hopefully the static content will move to S3. So that we're going to talk about the dynamic content we're serving here, and then the application servers you need for your web application. So again, demand increases. Really all we do in the console, and we can actually automate this, is say, look, we're going to add more servers, and then we're going to balance the load over those servers. So a really great service we offer for this, and I actually just covered a couple of them. First one is auto-scaling. So what happens is the demand goes up. We have CloudWatch running. CloudWatch is showing us, it's sort of a monitoring tool. CloudWatch is showing us what the CPU utilization is. And we're going to tell auto-scaling that when we reach a certain level of CPU, that we want to fire up another server. Let's call it a large. And we're going to spin up that server, and that's going to start handling the increased demand that we need for that application. And in many cases, we can actually now use tools like Chef and Puppet that help automate the elasticity fully, so that when the instance launches, it knows how to configure, and the instance will actually auto-configure. And so you're really getting true auto-scale even with a complex technology stack. And so that really can take a lot of the management complexity and help you really match your asset utilization to drive the costs of your applications down. So it's a great way where you can use these to then build more applications, more engagement, but still keep the overall cost and the manpower resources down. The other icon you saw show up there, that blue one, that's elastic load balancing, which is important. So if we put that on initially and then we auto-scale, what's going to happen is that load balancer is going to take all of that traffic, all that increased traffic, and it's going to balance it amongst your web tier. If we wanted to do the same thing for the application tier, what we do is we actually load a load balancer into Amazon EC2. We take that traffic, and then you would be distributed amongst your application tier services servers as they scale. So you can really start automating a lot of that process as well. So into the database, where a lot of issues lie when we start scaling. We're going to talk initially about a case where when we see increased demand, what we may want to do initially, we think we're going to add application servers, and then we're going to add a database server. When we start adding database servers, it can be really complex in terms of dealing with how do we separate the data set, and it increases even more complexity when we talk about redundancy or failover for that application once we start going to multiple instances or multiple servers for that database. And in some cases, and that's sort of what this would look like. Again, we can use auto-scaling to do this and handle the demand, and we can do this within EC2, Amazon EC2. But we also offer another service called Amazon ElastiCache, which is going to show up here, which may eliminate the need for that server. And so in many cases, what's happening is you're seeing really similar queries in that application hit the database. And a lot of people have been dealing with that with Memcached, and they basically have Memcached nodes, and they're handling these queries with Memcached. So we built a server that integrates with, or service that integrates with Memcached that, again, is scalable and available on demand. So you get just as much of the size of the cluster, the ElastiCache cluster that you need in terms of caching size based off of the database hits that you're getting. So you can cache as much as the little of your application. And in these cases where I'm talking more specifically about database queries, obviously you can use a cache to do many things. It really helps. It might help you stay within a more simplified architecture by just caching a lot of that. And again, available very simply through now Amazon ElastiCache. So we're going to talk about another issue that happens in the database that may not be CPU bottleneck on your database. This might be more on the I/O side of a bottleneck that starts happening. And so what we look at doing in this case is we offer a service called Amazon Relational Database Service, or Amazon RDS. And what you can think about this is basically it's a managed database service. It's offered for MySQL and it's offered for Oracle. Okay, and Obviously, there's advantages to doing that. One of the big ones, which actually we'll talk about in an upcoming slide, is with a click of a button, you can have synchronous replication of your master database, and you can set that up for auto failover. So if your master database goes down, it's not an asynchronous, right? These are actually synchronous replications. You'll just fail over, and if you've actually architected your application across multiple availability zones, your constituents may never know you had any issue at all. And that's all done on a managed side through Amazon RDS. Okay. In this case, we're going to talk about another feature that Amazon RDS has in terms of handling this increased demand. So we'd scale the application tier, but in this case, to take load off of the database, we're going to talk about read replicas. Again, you can just spin up a read replica through the console, really with just a couple clicks. And then what's going to happen is when we have these read replicas, you're going to direct the traffic of your read traffic of the application to the replica. That takes, again, a lot of I/O problems off of your database. It can handle mainly just writes. And so you can continually scale up those read replicas as you need to if your application is I/O bound in the database side. So that's really a nice feature, and it's really simple to do. So again, handling those that unpredictability of demand that happens when you make an application available to the public. These types of things can help you solve the problem that is hindering the performance of your application very quickly, and let you do so again in a way by you're just adding the service that you need, and you're just adding the amount of the service that you need to handle that application demand. So all of that, I'm sort of passionate about. I like the space, and I like what the services can do from an application perspective, but they have to be available for our customers to use them, and that has been a focus of Amazon's since the beginning. We architect every service to have high availability, and here's just a couple examples. Again, Amazon S3 itself is designed to be 4 nines available. Amazon RDS, again, we talked about before, you can have synchronous replication with auto failover literally with a single click in terms of when you set up the database. And then Amazon EC2, even if we're not architected across multiple availability zones, which we'll talk about actually on the next slide, it has a 9995 SLA for Amazon EC2 instances. So each service is architected for high availability. Actually, this reminded me, I was at a media event about 12 days ago, which is actually PBS was presenting at, and John Brensel was presenting, and he was talking about their availability actually moving from what he said was often closer to 1 9 and closer to 4 9s. And he received the question, are you architected across multiple availability zones for failure? And in this case, EC2 is sometimes its own worst enemy in this case. And Tom, I see you in the back, you might even mention this. They weren't, because they're getting closer to 4 9s across the entire organization for all their applications. And so they were, it was a step that hadn't been prioritized because of the fact EC2 itself had been architected so well to be available. However, a recommendation on best practices, and if you went to the best practices session earlier, they talked about this, is to leverage multiple fault-tolerant availability zones when you build these applications for reliability. And really, if we set this up correctly, what will happen is if an entire availability zone goes down, like the fire Kawaja was talking about in his presentation, that had taken down that entire data center, or if we had one there, took it down the entire availability zone, and you'd set up across multiple availability zones. When that instance goes down, that availability zone goes down, we're going to take the load balancer, it's going to transfer the load into the other availability zone. If you have auto-scaling set up and you've implemented elasticity, you may never even see a performance downgrade on your application. It's just going to spin up the next server. And again, this is something that you heard from Werner earlier today. He talks about really often, is everything fails all the time. You really have to design for failure. And someone who's actually done this really well and been really vocal about it, and you can get a lot of information online on their blogs, is Netflix. They actually, not only do they architect across multiple availability zones, they actually institute something called Chaos Monkey, which actually goes around and shuts down different resources randomly throughout their application. And so what it does is it ensures that all their engineers know that at any point, a portion of their application or resource that they have could be totally offline. And so they build it in to be resilient. And it doesn't mean that the application needs to be identical or that a portion of it can't be taken offline, but that there's an experience that the customer still has within that, within their different clients. That's a good experience for the customers, and they're able to do that by using multiple availability zones. And again, they're able to achieve what they call near zero downtime. So another thing that we need these resources to be is secure. And as you saw, actually CJ and Kwaja used the same slide this morning where they're talking about the way that we have the firewall after the physical interface, and then we have these security groups. And really what we're talking about here is setting up security groups. So we really recommend is you set up a security group around each tier. Okay? And so within each tier, what you're going to do, you can think of it as setting up a firewall around a selective set of your resources. In this case, we're talking about EC2. And so for your web tier, we put a security group around your web tier. You can enable access, say from port 80, port 443, so that they can actually access the application. However, for things going down to the web tier or the application tier and the database tier, you can only allow access, say, from your web servers to talk to the application server, and only say via SSH for engineers to actually work with the application tier. And so it's really, we could almost talk about security groups, that's the title of this slide, in terms of ways that you build that security into your application at each tier. So this is an example. Actually, we heard about this today, so I don't want to belabor the point. But this is something that was involved in the Recovery.gov process. As their former CIO, Jim Warren, had said, we basically just added our security to the security of Amazon. Many people actually talked on that point today. So that's something that it's sort of a flexibility of the platform, and in terms of we're giving you everything, from the OS up, and you can continue to configure the way that works best for your application. So there's a couple different ways we're really going to cut costs here too and make these less effective. So hopefully we can do more, run more, so we can be more engaging, we can have more transparency, but we can do so under what is not only a tight budget environment, but is likely to become a tighter budget environment. And budgets are never big enough, so there's always this constraint. And so one of the things that we talked about is just asset utilization. You can choose from assets that are going to be used 90% of the time, using things like reserved instances, to assets where you're less likely, where the demand is more fluctuating, we're going to use on-demand instances, to portions of the application where you may not care if that server's up or not, where you could use spot instances. And so you can really optimize. Werner talked about that as well in terms of really matching and achieving really efficient asset utilization. The next one we already talked about was Amazon S3 for your static content. It is, if you do a comparison, it is so much cheaper than running a server. And one of the things that we'd also talked about was experimentation today a lot is now when you get into a problem, like you set up your application, there's lots of different vendors out there that will basically mimic requests on your site. And so you can really load test these things and then start looking at the metrics of your application. You do that through CloudWatch. You can use CloudWatch custom metrics, which is a feature of our monitoring tool, so that you can actually look at very specific things in your application if you want to see where the blockers are coming out. And then you can actually add little bits of different services to start optimizing on a certain parameter. So in many cases, you can say, I want millisecond per request of my application to be X. You can actually set that performance goal, and you can start working on that from tweaking different portions of the application to make that work, while still then optimizing your costs. So you can really set these very finite objectives for your application by using these on-demand and scalable services. So we encourage you to test. So another thing is, like, when should we think about applications? Well, obviously new development, new things come up, we want to add a feature, we think that's a great use. from our customers is really the other use on the migration. What we've seen is that they really look to applications on AWS. A lot of times when they've had an application failure, sort of like an outage that we talked about before, where they had trouble managing demand, or they were growing so quickly that they had a bunch of single points of failure they didn't know about within their application. That's one of those. Another one is just poor performance of the application. They want to improve the performance and the user experience. We've seen it after they've had a problem with security. We've seen those customers, if they're just upgrading. So if they're upgrading their CMS, if they're upgrading the overall application, they have to do that anyway. It's actually a really great time to think about, a way you can come in and take advantage of the services, whether it's just a straight cost reduction or whether it's to comply with the data center reduction initiative. So just here's a couple different architectures I wanted to throw up. One of which is essentially your static website, which is just Amazon S3 and CloudFront. Another one is a very basic dynamic website where it's not going to be a lot of traffic. You're actually willing to put the database, the application, and serve content from the same instance. And you just want, in this case, we actually recommend, again, from usually a cost and always a performance perspective, but usually from a cost perspective as well, using Amazon CloudFront with that Amazon EC2 instance. And so you can really just stand up these real basic websites. What I've heard from customers is when this works well, is if there's small, sort of, again, these basic dynamic sites that a bunch of different people within the organization need, where they're actually getting requests to IT for those resources, they can set this up, and so people can get access to sort of these basic sites that they need to run their line of business or something that's within their work section. And then we have what I call just sort of a more dynamic application. It's built to be more robust with auto scaling, with in this case, the EBS volumes. This one is the Amazon RDS. It's got the managed database, so we're separating the tiers out in terms of how we look at that. And then again, a high availability dynamic application, which is really where we started going down tier by tier, which is, again, what we recommend from a availability perspective, but we understand that there's different needs out there for our customers, and the services can be used in a different way. One point I like to bring up that's not on the slide is using the browser as your application tier. And in this case, we're using tools like Amazon SimpleDB with S3. And Amazon SimpleDB is generally what we think of as our NoSQL database offering, where we actually let the application is really sitting on the browser. HTML5 enables this. A lot of times you can just do it with JavaScript. But you can actually start building applications that will recognize a personalized user, deliver back actually personalized content without a server. And we see more and more people experiment with that today, with using what's actually on the browser to do the CPU of the application. The cost of those applications is so low, it's pretty hard to talk about. But it takes sort of a rethinking of an application. So generally, you're not going to take an application that's running today and do that, although you could migrate to that. But I see a lot of people thinking of new development in those ways and using tools to index object stores, which is what, again, you can do really well with Amazon SimpleDB to then actually serve that user's content directly to them, which is really neat. So we offer a couple more services, and this is sort of where the breadth of services comes in and really brings the whole story of web applications together. In this case, we have two I want to talk about very quickly: are Amazon Elastic Beanstalk and Amazon CloudFormation. Amazon Elastic Beanstalk, really this boils down to, I have a WAR file, I'm going to submit it, I'm going to hit a button, I'm going to go through a simple interface, and I'm done. It will scale it for me. I'm basically done with that application. It's going to run. What we happen to do is we actually give you access to each individual resource. So at some point, if you want to actually tune the performance of the application or experiment with different resources, you can get back in and start tuning that application. But if not, we'll just continue to, again, it just works like an application container. Continue to run and scale that application for you based off of demand. The next one is CloudFormation. So one of the examples that's at the top of this is actually a Drupal template There's a bunch of different templates. So you can think of this like a recipe for AWS resources. So you say, well, look, I want to run a Drupal website. We have pre-built CloudFormation templates. You just click the button. What happens is you'll have Amazon EC2 instances stand up, configured with Drupal. In this case, I think it launches a MySQL database with that template, and you can scroll through to see what that is. So all of a sudden, again, in minutes, all your resources that you use are up, and you can build these and customize them yourself. Again, that really helps with it really helps with launching new instances and with actually, in many cases, managing instances across an organization. You can say, look, you can choose from these 8 templates, and the templates are already set up, and so they can click the template. They have the template, load source code, and their application's up and running. So really, again, to sort of recap is what really helps in terms of this unpredictable demand that we're talking about, this variable demand, is a set of truly elastic and scalable services that are available on demand. That was the key. But again, to utilize those, we really need all those services to be secure, reliable, and cost-effective. I want to thank you for your time today.